When you start learning to code, you usually write a simple script to print "Hello World" on your screen. Getting that to run feels great, but realize this is just basic programming. It is the equivalent of snapping together a single toy building block. Now, compare that simple script to the massive digital platforms we use every day, like a global shopping site or a video sharing app. These projects contain thousands of interconnected files, millions of lines of code, and require hundreds of developers working for years. Imagine 100 different developers sitting down and typing out code for the exact same project at the exact same time without a shared plan. It would be a disaster. You cannot build a digital skyscraper using toy block methods. To prevent total chaos, you need an overarching system to organize all of those people and all of that code. A lot of beginners assume that the word software is simply another word for code. Software is a combination of three elements: the programs, the data, and the documentation. In a messaging app, you have the code, plus databases of messages, user profiles, and update logs. All of these pieces combined make up the software. Think about how a physical hospital is built. The construction workers don't just show up on an empty lot and start laying bricks. First, architects have to figure out the budget, the floors, and exactly where the electricity and water lines go. Digital structures require the exact same preparation. Before anyone starts typing code, software engineers systematically map out the entire project from top to bottom. This practice of taking those same logical construction steps, planning, designing, and calculating, and using them to build apps is what we call software engineering. Before coding, a project moves through analyzing requirements, planning, and design. Only then does the coding phase begin as one task in a larger line. Finally, the team moves to testing, deployment, and long-term maintenance. Without this structure, an amateur programmer falls into a stressful cycle. Write some code, find a bug, scramble to fix it, create another bug, and panic. Being systematic means strictly following this organized sequence. It is how a team safely guides a project from a raw idea into a stable, long-lasting product. Teams go through this massive planning pipeline for a very specific reason. Large tech projects have to hit rigid performance and business targets. This radar chart maps out those targets, starting with quality, reliability, and efficiency. If you are building a banking app, the math has to be completely accurate every single time. A single crash or a miscalculated transfer breaks the user's trust immediately. But the app working perfectly isn't enough. The team also has to hit logistical targets, like finishing the project on time and within budget, while making sure the code is easy for other developers to modify later. A large project only succeeds if it delivers exactly what the customer requested, works absolutely flawlessly, and avoids wasting time or money. This brings us to the ultimate difference between the job of a programmer and the job of a software engineer. Looking at this circle diagram, we can see that programming sits entirely inside a much larger discipline. Programming is the specific action of writing the code, while software engineering is the entire process of planning, designing, checking, and updating the system. To see if you have a solid grip on this, ask yourself 3 questions. Is every programmer an engineer? Why is coding just one piece of the puzzle? And why is it impossible to build massive applications without planning? When you can answer those, you have moved past simply writing lines of code and begun to understand how entire systems are built. Moving from the bricks to the blueprint is the core of software engineering.